in this episode, U-Substitution. How to use this technique to do integration. Coming up, back into action. Hey guys, U-Substitution for integration. How to use this technique when you integrate your expression. And why do we need to use it? So I'm going to answer to all of these questions, and I'm going to come up with some basic examples to show you how it works. Yes, these examples gonna be just basic kinds, but things unfortunately might get more complicated and more sophisticated, so that's coming up. Now, the idea, the gist is, you want to rewrite your integral, the expression what you are given, your basically integrand, what you have in your integral symbol, in terms of another new variable u that you are going to define. Well, why do we need to use this new variable u? Because we want to make our integral easier than it was at the beginning. Look at this. You have one term multiplied by another term raised to the 8th power. Alright, you might come up with just straight up idea to raise this binomial to the 8th power and multiply things out, distribute, so you might come up with some algebra. Yes, technically, theoretically, you can do, but just think, this binomial raised to the 8th power, well, it might take you maybe 2 or 3 days or even 1 week to just finish with this algebra stuff. Well, it's not the way. And another technique that basically should be used here is U-substitution. Well, it's called U-substitution, but any other variable could be used to rewrite your integral in terms of the new variable. You could use t, v, a, or whatever letter you like. Now, your first step always, you want to make your u. Let's stick to u. You want to define your new variable u as a sum expression in terms of x. Your u, in this case, it's gonna be this entire parenthesis, what you have as your binomial here. This one is gonna be u. Why? If you look at this carefully, the derivative of this expression, namely a half x to the 4th minus 3, is gonna be 2x cubed. It's gonna be what's left over. So this term, by making this term, this u, would perfectly work for our substitution, because the point is we want to rewrite everything in terms of u, so no dx would be in your new integral. Instead of dx, you would have something du, and this du will also need to define actually. Alright, so we're going to make your u is this entire expression. So it's gonna be a half x to the 4th minus 3. Now, we need to also express this leftover, basically. You have this 2x over here, and this dx sticks out. So all you need to do is just find du. You need to find differential of u by taking the derivative of this expression. So you just basically take the derivative of this part and that part. Just take the normal derivative. Now, since you have a constant and the power of the term, you use a power rule as normal, so you would simply have, you keep the constant, you bring this 4 out front, that gets multiplied by 4, and you reduce your power by 1. So 4 minus 1 gives you 3, and this negative 3, since this is a constant and the derivative of a constant is just 0, so your constant basically magically disappears. So it drops out, and at the very end you have to add dx, because this is differential du, differential of u, so that means you should take the derivative of this expression in terms of x, and you have to attach, you have to tack on dx at the very end, so times dx. And I would just simply simplify it, so 2 goes into 4 twice, and you would be left with this expression. Now, that's basically what we wanted. We wanted this 2x cubed dx to be replaced with du. Alright? Now we are ready. We are ready to substitute. So again, instead of this, what we have inside the parentheses, inside the power, because power you have outside. So this is your u, so we make our substitution, we make our new variable u to be this expression inside. Now, what's left over, namely 2x cubed, and this dx sticks out, we're going to replace with du. No x at all. We would have a new integral in terms of du. So it becomes integral u, and this one I'm going to write just at the very end. So typically, normally we write dx, du, dt, whatever this differential, it comes at the end. And you have this power, so you have u to this 8th power du. Now at this point there is no x, forget about x for now. You have a new integral, and this is much easier than that one, and hopefully you recognize this integral. This is normal power rule, so you have power of your term, so you have power rule for integration, so you apply a power rule. So the power rule says all you need to do, you just raise your power by 1, so 8 plus 1 becomes 9, and you divide it by this new power 9. And since you have indefinite integral, there is no limits, it's not a definite integral, this is indefinite integral, you have to add plus c at the very end. So all these types of integrals, they require this arbitrary constant of integration that's typically named after c. Now we did integrate, we kind of got rid of this integral symbol, it disappeared, it goes away, du as well, when we integrated, both of them drop out. But we are not done. At this point, we have to back substitute. Many people forget about this, and as soon as they got the integral, they leave the answer this way. No. Because your original integral is written explicitly in terms of x. Your answer has to be written explicitly in terms of x, not in terms of other variable, u, t, or whatever. So we get back substitute. So instead of u, I'm just going to write that original expression, that one. This is my favorite part. So the last step, finally the last step. So instead of u, I'm going to rewrite this expression, which is basically a half x to the fourth minus 3. So u power is 9 in u power over 9 plus c. This is your final answer. This is your final integral for that one. One little disclaimer. This is, as I mentioned before, the most basic, the most perfect, ideal type of integrals that might come up when you do U-substitution. Sometimes you have to manipulate, sometimes you have to rearrange your du, sometimes it does not perfectly fit over there. So here, when we found du, it perfectly fits this expression into your integral, into your integrand, what's left over. But sometimes you have either constant or negative sign, and you have to kind of convert, transform, or manipulate, rearrange your du in order to make this fit, to fit it into what you have. So this stuff, these examples coming up. All right, one more to go. Suppose you are given that integral. Let's take it. Well, your u is gonna be what you have inside. So as a general rule of thumb, like generally, when it comes to picking your u expression, sometimes it's not that easy to come up with the u, to define your u. But as a good rule of thumb, it should be like the longer expression that appears in your problem, and it's usually like inside your power, like we did in the first example, or here, underneath your root, for example, on the bottom of your fraction, or it could be power of a trig function like sine of cubed x, so this sine x would be your u. So sometimes you are already given u when you do some problems, and at that point you are lucky. You are lucky one. But again, if you pick your u wrongly and your integral does not get simpler than it was before, so you cannot integrate it after when you substitute, so you could always get back and you pick your u being another variable or another expression. So it's not that the end of the world. So just if it doesn't work, you could always get back and try to use algebra and just pick your u. But at these basic examples, so usually your u like kinda the longest expression that pops out at you, and also sometimes also you are given like the derivative of this expression. Now at this point your u is going to be what we have inside this this square. So this 2x plus 5 we are going to define to be u. So make u substitution u to be this expression. So the next step, we need to find du, differential. So differential du, you simply take the derivative from both sides. So the derivative of this is just 2. And since 5 is a constant and the derivative of constant is just 0, so 5 drops out. And don't forget to attach the x at the very end. Now, if you look at your original expression, so we don't have this 2, but here we have. So at this point, you need to rearrange your du, your differential, a little bit in order to fit it into your integral, what you have. So in order to do this, just divide both sides by 2 and you would get your dx. So your dx, what we are going to substitute, would be replaced with du over 2. Now we're ready. Everything is ready and we can make that substitution, U-substitution. So it becomes the integral. So instead of 2x plus 5, I'm going to write u, and you keep this power, square. And my dx, it simply is replaced by du over 2. So instead of dx, I'm going to write that du over 2, since your dx, it's precisely du over 2. So everything is replaced, so we don't have any x, we have a completely new integral, and at this point it has to be recognizable, so it should be better, it should be easier than it was before, and basically it is. So all you need to do is just little simplify and you would be left with your du over u squared. And at this point, so power rule is your friend here. But before we apply power rule, just again little bit tweak. So you have your term with second power down in the denominator. You want to bring it up by making your power negative, and you want to fit it into a power rule for integration. So it simply becomes u to the negative 2 du. So just recall and think back when you have your power down in the denominator and you want to change it, you want to bring it up to the top, so you have to make it negative. Now at this point we are ready to apply a power rule for integration. So all it says that you need to just add 1 to your power and divide your term by this new power, which is minus 2 plus 1. And at this point it requires the arbitrary constant of integration that is typically denoted by c. Now simplify it down a little bit, so your power actually becomes just negative 1, and I'm going to pull out this negative 1 out front, so negative a half. This is my constant, you keep it outside, and you are left with u to the negative 1 plus c. And another step, you get back, you want to put your u down in the denominator by making your power positive, negative 1 over 2u plus c. So I'm not going to write 1 as a power here. It's implied to be 1. Normally we typically just omit, we neglect this power of 1. And finally, hopefully, the last step when we back substitute. So you don't want to leave your answer with the U, because U it's like new variable, we use it, now we don't need it anymore. We're going to get rid of this U and back substitute to X. So instead of U, I'm going to place to X plus 5. So -1 to X plus 5. And you have this constant out front plus C. So this is your final integral. This is your final answer for that problem. I hope it helps you guys. Thanks for watching and train your brain. I know everyone hates maths, but if you like my video, please share with your friends, hit like button, leave the comments down below, and smash subscribe so you will not miss out my new videos.